Hello, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at factoring by grouping. It's a technique that is sometimes used for certain types of expressions, and it's a technique that's used to explain factoring a certain type of trinomial. So the idea of doing the factoring this way is that you partially factor different parts of the expression. So I think it's best I can best explain it with an example. So if I take a look at this expression here, I notice that there is a common factor of 5 in those two terms. There's a common factor of 2x in those two terms. So I'm going to factor these two terms. I'm going to factor that 5 out, and I'll be left with a plus 2b. I'm going to factor a 2x out of these two terms, and I'll be left with a plus 2b. Now, hopefully you've noticed that this factor of that term is the same as this factor in that term. So now what I'm going to do is I'm going to factor that expression out. It's a factor, so I can do it, but I'm going to factor it out of both of those terms. So it's like if I had 5m plus 2xm, and I factor out an m, and I'm left with 5 plus 2x. That's what I'm doing, but it's not an m I'm working with, it's this whole expression. But that's okay, I can do it. So I'm going to factor out an a plus 2b, it's just like I factored out the m there, and I'm left with 5 plus 2x. So that procedure allowed me to factor this expression. Let's take a look at another example. This is a specific type of example that we will be getting into when we're factoring trinomials, or a certain type of trinomial, in an upcoming video. And you might think, well, why don't I combine these terms? Because I can combine negative 8t plus 15t. But I actually, when I explain the technique for factoring a certain type of trinomial, we're going to break terms into, our expressions into this type of expression. So just go with it. Don't worry, don't question why I'm doing it. When it's broken up like this, instead of those two terms combined, it will allow me to factor this expression by grouping. I can factor 2t out of these two terms, and I'm left with 3t minus 4. Then I look at these next two terms, and I can factor a 5 out of each of those, and I'm left with 3t minus 4. And you'll notice again that this factor in this term is the same, and it has to be the same exactly as this factor in this term. If they're not the same, then there's nothing you can do, and you wouldn't have done this partially factoring. We're only doing this so that we can totally factor the expression. So now I'm going to factor this factor out of both terms, this term and this term. So I take a 3t minus 4 out, and I'm left with, when I take a 3t minus 4 out of this term, I'm left with 2t. When I factor 3t minus 4 out of that term, I'm left with a 5. So that process of factoring by grouping allowed me to factor that expression. Let's look at a few more examples. In this expression, we have no like terms that we can combine, so there's nothing we can simplify. The instructions have asked me to factor, so I'm often, when I have 4 terms, I'm going to see if I can factor by grouping. So I notice that I can factor out a c out of these two terms, so I'm going to do that. Now there's nothing common to those two terms. However, I noticed that this term contains a factor of m plus n. That means that I can express this as 1 times m plus n, so that I have the same factor in both terms. Now I'm back to where I was in the last examples, where I have a common factor to each term. I factor that m plus n out, and when I factor it out of this term, I'm left with a c. When I factor it out of this term, I'm left with plus 1. So that's now considered factored. A lot of students miss that 1 and they just kind of ignore it. You can't ignore it. It's there, even though you don't see it, but you have to understand that it's when you've got a factor and no coefficient, it means it's being multiplied to a coefficient of 1. And one more example. This example is a little bit different than the previous ones that we did. In the previous ones, we grouped 2 terms and 2 terms, and we factored out of each of those. I could try this here. I noticed that the x is common to both of these terms. And then I noticed, oh, there's nothing common there, but that's a difference of squares. So, okay, let's try that. Y plus 3 times y minus 3. However, it doesn't get us anywhere because there's nothing common to this term and this term. So I want to think of grouping a little bit differently this time. I'm going to group these 3 terms together because that's actually considered a special product. And if you have been working with products of polynomials, hopefully you can maybe recognize it as well. But this represents x plus y squared. Now you can expand this and multiply to see that it gets that, but if you recognize these special, when you've been working with them, you often can recognize them a little bit faster or easier. So that factors into a square, and then I have minus 9 I can think of as 3 squared. Now there's nothing common to each term, but by grouping them in that manner, I have now produced a difference of squares, and I can factor a difference of squares. So my factors are, remember, if I have a squared minus b squared, the factors are a plus b times a minus b. So my factors will be x plus y plus 3 and x plus y minus 3. Just following that pattern. So it might be a little more difficult to notice that grouping in this particular example, but if you're asked to factor, sometimes you just have to be creative and move things around and just try things. If it doesn't work, you just erase it, try again. So as usual, try some of these. I'm sure you've got some in your textbook, or look online for more questions. And the next video that I will be producing is going to be on factoring trinomials. So some of what I did here, I will be referring to in the next video. So practice factoring by grouping, and when you're ready, join me for factoring trinomials. Take care. See you then.